Okay, now let's start something totally new. Let's talk about trigonometric functions and the derivatives of trigonometric functions. Okay, so our basic definition of trigonometric function is the following. So let's consider this unit circle. This is 1. Okay, so this is unit circle. So we take any point here. Okay, call this angle theta. So we define cosine theta and sine theta as the coordinates of this thing. Okay, so this height is sine theta, and this length is cosine theta. So that's our basic definition. Just to remind you what we are doing. And the graphs are simple. Okay, so the sine function is something like this, periodic. It keeps on going like this. So this is y equals sine x. Okay, so it oscillates between +1 and -1. Okay, so also on this side. And the graph of, if this is pi over 2, and the graph of cosine x is you just push it here. Now what you see is the graph of cosine x. Okay, so then we have tangent. The other trigonometric functions are ratios or combinations of these. Okay, so what we are trying to understand at this point, since we are talking about derivatives, is derivative of sine x. Okay, so for this thing we will need a certain limit. Derivative of sine theta over theta as theta goes to 0 is the crucial calculation in calculating the derivative of sine x. So let me start with these. Okay, so a question. So we want to calculate derivatives of trigonometric functions. Okay, so let me motivate this by okay, so I'll need it over here. Okay, so for example, let's start with sine x derivative. Okay, so I'm just writing the definition now. So delta x goes to 0 of sine x plus delta x minus sine x divided by delta x. We use the addition rule for trigonometric functions. Limit delta x goes to 0 of sine x cosine delta x plus sine delta x cosine x minus sine x divided by delta x. Okay, so I think, so where do we can take sine x, so limit delta x goes to 0, sine x times cosine delta x minus 1 over delta x plus, okay, I'll have another limit here, the other term, limit delta x goes to 0 of this thing, sine delta x over delta x cosine x. Okay, so you see that I have this limit appearing crucially. So to emphasize that, let me pull delta x over here, or just to make it cosmetically impressive, let me write cosine delta x minus 1. Okay, this one. Okay. You see, I know the limit of this. Cosine is continuous, so cosine 0 is 1. 1 minus 1 is 0. This will be 0. And here, cosine x is constant when delta x is going to 0, so that is understood. All I have to do is understand this limit. If limit of sine x over delta x as I made some, okay, so I have this thing here, right? This is delta x, this is sine x. Okay, so now I have to understand these two limits. Okay. Because sine x is constant as delta x goes to 0. Okay, so this is 0 over 0 because cosine delta x is 1 when delta x is 0. Okay, minus 1, 0. And this is also 0 over 0. So I need to understand these two limits. And that will give me, if this is a number here, that's a number here, so the limit will be a combination of these things. So we need to understand these limits. Okay, so to understand these limits, so we go to the definition of trigonometric functions. Okay, so I think I'll do something like this. Okay, so let me give everything a name. So this is theta, this is A, B, C, D. And I think I need also this E. Okay, now I will compare areas here. Okay, so the area of this right triangle, this one, is less than the area of this sector, and that's less than the area of this big triangle. So that's what I'll try to write. So let me write it like this. So first of all, I am interested in this area. So area of triangle AED. Okay, so that's strictly less than. So the other one is, next I'm interested in this sector. So area of sector ADB, and that's strictly less than. Okay, so this is the big triangle now. Okay, so I'll do this. Area of triangle ABC. Okay, so this is clear. Now I want to write these in terms of theta. This is the unit circle, so this is 1. So this is unit circle, which means that the coordinates of D are cosine theta. Well, I call this okay, sine theta. Okay, so what is the area of ADE? Okay, so this side is cosine theta. First of all, this is 1 over 2. This side is cosine theta. Height is sine theta. This is less than area of sector A or B. Well, the area of the whole circle is pi, right? Pi r square, r is 1. So the whole area of the circle is 1. And instead of using 2 pi, I'm only using theta. So this is theta over 2 pi. Okay, so that's the usual formula. Half the radian gives you the area of the sector in unit circle. But who is going to memorize that? You just write it like this. And that is less than area of a triangle, so I have 1 over 2. Okay, so this whole side is 1. So what is this side? Okay, so this side over this side is tangent of theta. This side is 1. Okay, so it means that CB is tangent of theta. Okay, so this is tangent of theta, but since I have sines and cosines, let's write this as sine theta over cosine theta. Okay, let's get rid of 1 over 2's. So we throw these 1 over 2's here. And multiply by cosine theta and divide by, so multiply by, I want to multiply everything by cosine theta and divide by sine theta. Why? Because I'm trying here to get theta over sine theta or sine theta over theta. So these pi's are also canceling. Okay. So here I have multiplied this by this. I have cosine squared theta less than theta over sine theta, and that's less than what? 1, right? Does everyone agree? Everyone is. I multiply this by cos theta sine theta. Here I have cosine theta, right? Okay, so I don't want that, so let's just divide by cosine theta. 1 over this. So this is, here I have cosine theta, and here I have 1 over cosine theta. Okay? Okay, how about this one now? Okay? Does everyone like it? I'm interested in this one, sine something over something. So let's take reciprocals of this. Okay? When you take reciprocals, the signs will be reversed. Okay? This is going to be cosine less than. So I have actually, so take reciprocals. Nothing is 0 yet. Okay, so I have cosine theta, reciprocal of this is less than sine theta over theta. That's less than 1 over cosine theta. Okay, now cosine theta is a nice function. It is continuous. Okay, well, we did, I think we did this continuity last week. So when theta goes to 0, cosine theta goes to cosine 0, which is 1. Okay, so I can take limits now. This goes to 1. This goes 1 over 1 as theta goes to 0. So this is squeezed in between, and it has to go 1. Okay, so limit. So limit theta goes to 0 of sine theta over theta is 1. Actually, if you draw the graph of this, you will see something like this. Okay, so here is 1, and then it goes something like this. Okay, and it will probably oscillate here because sine theta becomes negative, but this is close to 0. Okay, so this is theta. This is y. This is y equals sine theta over theta. Okay, so this is the graph of this. Well, here I'm not suggesting that it goes here. This will oscillate. Okay, but just around 0, it will look like this way, also from this side. So only this point is missing, and the function is nicely approaching there. So again, if you experiment if you draw the graph, you expect the limit to be 1, and you calculate it rigorously, and it's again 1. Okay, so now we are safe. Okay, so we calculated this limit to be 1. How about this one? So let's also look at that one. Next semester, if we are all here, we'll look at Taylor series expansion of sine theta. Taylor series of sine theta begins with theta minus 1 over 2 theta square plus etc. So when you divide it by theta, you have 1 minus, and then everything else is multiplied by theta. When theta goes to 0, everything disappears, and this 1 remains. Okay, so that will be verified next semester when we do something more strong. But you cannot do that before you know the derivative of sine theta. And in order to know the derivative of sine theta, you have to use such elementary considerations. Okay, so what about the other one? So what about limit theta goes to 0 of, so what was it? Cosine theta minus 1 over theta. Okay, so we do, if nothing comes to mind, you do this cosine theta plus 1 over cosine theta plus 1. Okay. Or let me do this in the next step so that we know that we are trying to calculate this. So let's check. Limit theta goes to 0, cosine theta minus 1 over theta times cosine theta plus 1 over cosine theta plus 1. Okay, so this is going to be limit as theta goes to 0, cosine squared theta minus 1 over theta times cosine theta plus 1. Okay, I can recognize cosine squared theta minus 1 as what? Minus sine squared theta is equal to minus limit theta goes to 0 of sine squared theta over theta cosine theta plus 1. I can now bring it. You see, now I have sine theta over theta. I know what that is. Okay, I rewrite this as minus limit theta goes to 0 sine theta over theta times limit of a product, if all the terms exist, is sine theta over cosine theta plus 1. Okay, so all these limits exist. Minus 1 times, this is 1. This is 0 over 2. So this is 0 is 0. Okay, so that limit is 0. But here we realize that we can show off. Instead of dividing by theta, I can divide it by theta squared and still get some nice limit. You see, because here I have an extra sine theta, I could still divide it by theta. It would also give me something. And then I would get 1 over cosine theta plus 1. As theta goes to 0, the answer will be 1 over 2. Okay, so let's also do that. We notice the following. Okay, so let's calculate limit theta goes to 0. Okay, so we found out that this cosine theta minus 1 looks nice, but it gives us a minus at the end. So let's write it the other way around, not to get a minus sign. Nothing wrong with minus sign, but aesthetics. Okay, so 1 minus cosine theta, and I'm dividing it by theta squared this time. Okay, so we notice that we can calculate this and still get a number. Okay, so I'll do the same thing. Limit theta goes to 0, 1 minus cosine theta over theta squared times 1 plus cosine theta over 1 plus cosine theta. So this is limit theta goes to 0 of, now this is 1 minus cosine squared theta over theta squared times 1 plus cosine theta. Okay, so this is limit theta goes to 0 of sine squared theta over theta squared 1 plus cosine theta. Okay, so now I can use the previous limit. So this is now equal to limit theta goes to 0 of sine theta over theta squared times limit theta goes to 0 of 1 over 1 plus cosine theta. Okay, so now I know both limits. So this is going to be 1 over 2. Cosine is continuous. And sine theta over theta goes to 1. As theta goes to 0, its square will go to 1. Okay, so this is equal to 1 times 1 over 2. So to be funny, let's put square there. Okay, so the limit is 1 over 2. So this thing, even though you are dividing by square of theta, still gives you 1 over 2. So again, next semester when we do Taylor series, we will verify this. But let me repeat that you can't do Taylor series of cosine if you don't know the derivative of cosine, and these things will be used. Okay, so with this information, let's go back and calculate the limit, the derivatives of sine and cosine using these basic concepts. Okay, so everybody knows from high school that the derivative of one of them is the other, and there is one minus somewhere. One of them has minus. Okay, so let's check if we can derive those formulas using our basic definition of derivative. Okay, so again, let me do it this way. Back to derivative of sine and cosine. Okay, so let's start again from the beginning. Now we have more information. I want to calculate the derivative of this. This is limit delta x goes to 0 of sine x plus delta x minus sine x over delta x. So I use addition formulas. Okay. Here I have sine x cosine delta x plus sine delta x cosine x minus this sine x over delta x. As we did before, okay, so I'll take this one together with this one. Sine x is constant, so I take it out. Sine x times limit delta x goes to 0 of cosine delta x minus 1 over delta x. You see, I know that this limit is going to be 0 plus here cosine x is constant, so I take it out. Cosine x limit delta x goes to 0 of sine delta x over delta x. Okay? So I know that this limit is 1. Using the fact that this limit is 1, using the fact that that limit is 1, we managed to calculate the other limit. So this limit is very fundamental. Sine theta over theta going to 1 as theta goes to 0. Okay? But I want to remind one more thing about this. I think I erased this anyway. In calculating that limit, in calculating this limit, at some point we use the area of the sector. Okay? In that formula, we explicitly use the fact that we are measuring the angle by radians. If you measure the angle by degrees, then that area will have a different formula. There will be different factors there, pi over 108 or something like this. Okay? Then this limit will not be 1. This limit will be pi over 1 over 108 or 108 over pi, something like this. Okay, so it is crucial for these things to work that you calculate everything in radians. So that's why in calculus, all angles are in radians, so that the derivative of sine and cosine will be nice. Okay, so now we know these limits. Okay, so this limit is 1. This is equal to 1. We calculated this limit to be 0. Okay, so you see that then this limit is cosine x. Okay, so we found the following: sine x derivative is cosine x. So we knew this from high school, but now we show that our basic definitions also give this. Let us check if the other one works. Okay, so cosine x prime. We'll again use the usual definition, delta x. Okay, cosine x plus delta x minus cosine x over delta x. Now we use addition formulas like we did here. Okay, so this should work, but just let's be careful so that we don't make plus or minus errors somewhere. So this is cosine x times cosine delta x minus sine x times sine delta x. Okay, so last year this was the formula. So let's use it again. Minus cosine x over delta x. So as we did here, if something works, you use it until it doesn't work, okay? So that's the usual rule, philosophy in life, okay? If it works, don't touch it. Okay, engineers know that better than we do. Okay, so this worked here, so let's use it. So now here, again, I'll use this part and say this part. Cosine x is constant with respect to delta, and delta goes to 0, so I take cosine x out, just like we did here. Then we have limit delta x goes to 0. Then I have cosine delta x minus 1 divided by delta x. Well, this is the same limit I had here. This is going to be 0. So far, so good. Then I have plus. Then I have this thing here. Well, okay, I have minus now. That minus, this is the minus that comes out. Okay, so let us make a note of this. This is minus sine x. And here I have limit delta x goes to 0 of sine delta x over delta x. Okay, so this again as before. So this part is 0. Okay, so this is 0. And this fundamental limit is 1 equals 1. Okay, so the derivative, the result of this limit calculation is minus sine x. So we confirmed our formula that derivative of cosine is minus sine using the basic definitions. Okay. Again, I'll repeat once more that you have to arrange your calculators that all angles are measured in radians. Otherwise, the numbers you get will not be correct. Okay? Because if delta x is measured in degrees, this limit is not 1. It's a different number. And you can find what that number is. Then the derivative of sine prime will be that number times cosine x. Okay? You see, that's what we have here. Okay, so I think we have. Since the quiz is very easy, I'm trying to go slowly, but I think I covered everything I planned for this Friday. So let's have the quiz. Okay, it's an easy quiz.